Okay, so what we're going to do is review how to write Lewis formulas or structural diagrams. And we're just going to start right in. So the first example is going to be methane, CH4. So there's a series of steps here, and the bottom line is you have to follow the steps. My experience over the course of the year has been that 99% of you, both Chem 8 and Chem 7, don't follow the steps. All right, step number one is that you have to count the total valence electrons. If you don't count the total valence electrons, whatever structure you end up drawing is going to be wrong. I repeat, it will be wrong. So the first thing we're going to do is count the valence electrons. We have carbon here that is out of group 4A. So there are 4 valence electrons accounting for the carbon. Then we have 4 hydrogens that come from group 1A. All right, and 1A means that there's 1 valence electron for each atom. So the total here is going to be 8 valence electrons. This I call my magic number. Whenever we finish with the structure, we have to make sure that the number of valence electrons we used in the structure exactly matches this number. If that is not the case, then no matter what you did, no matter how beautiful it looks to you, the structure is incorrect. Step number 1 is to count the total valence electrons. Step number 2 is to draw the skeleton structure. The central atom is written down first. Then the other atoms are placed around the central atom this way. You sort of place them so they're as far apart from one another as possible. The next step, we connect the central atom with the external atoms using dashes. Each dash has 2 electrons in it. Once we have connected the central atom to the external atoms, then what we would do next, and in this structure we don't have that problem, but what we would do next if we haven't used up all of the electrons that we started with, which is 8 here, then we would place the remaining electrons as unshared pairs, starting on the central atom so as to have 8, and then we would move to the external atoms and place the remaining pairs there. We do not have that issue here, and we'll see how that works on the next molecule that we do. So finishing for this structure, we have to run 2 tests. The first test, we need to recount the total valence. And what we're looking for here is to make sure that we used exactly the number of electrons indicated by the magic number. So I'm going to go over here and count. We have 2, 4, 6, 8. A total of 8 electrons in the structure, and that number matches this number. So our structure meets test number 1. The second test is called the octet rule. And what this says is that we need to have 8 electrons around all atoms except hydrogen. And hydrogen can only have 2 electrons next to it. All right, so we come back over here and we look at the carbon and we see we have 2, 4, 6, 8 electrons around it. So this meets test number 2. And the hydrogens all have only 2 electrons that they're next to. So this is the best possible structure. All right, moving on to the next molecule, we're going to look at H2O. Now, again, we're going to count the total valence. We do not blow that step off. We count the total valence. Hydrogen is out of group 1A, and there are 2 of them. So we're going to have two atoms of hydrogen, and each one is worth 1 valence electrons. And then that is going to be plus oxygen, which is out of group 6A for 6 valence. The magic number is going to be 8 electrons. Now I do the skeletal structure. The easiest thing to do is just put the 2 hydrogens on opposite sides of the oxygen, as far away from one another as possible. The next step is to go ahead and connect the external atoms to the central atom. And then we're going to place the remaining pairs starting on the central atom so as to produce a total of 8 electrons around the central atom. And we can see there are 2, 4, 6, 8 electrons here. So we've used all 8 of the total. So let's just go right to the test. So test number 1 is the total valence electron count. And what we see for this is a total of 8. That number matches this number. So we know that our structure has met test number 1. Test number 2 is to make sure we have the octet rule. In this case, for the central atom of O. And we see there's 2, 4, 6, 8 electrons around it. So we've met that rule. So this is most likely the best structure for H2O. Noting that I did not ignore them, the hydrogens are perfect because there are only 2 electrons next to them. We would not add any more electrons to a hydrogen ever. It only can be next to 2 electrons. All right, moving to a new screen. We'll do carbon tetrachloride next. So, first things, valence count. Carbon is out of group 4, so there are 4 valence electrons. Cl is coming out of group 7, and there are 4 of them. Coming out of group 7, there are 7 valence electrons. So this is going to be 28 plus 4. 8 and 4 is 12. 2 carry the 1. So there's going to be a total of 32 electrons for the magic number. Okay, next, we draw the skeletal structure. We start with the central atom and we put the CLs around the central atom. So they're as far apart as possible. Then we're going to go in and we're going to connect the central atom to the external atoms. Here we've used a total of 8 electrons. We've got a ton of them to go. So the remaining electrons will go in as pairs. Normally we would start with the central atom except for the fact that there's already 8 electrons around it. 2, 4, 6, 8. So we place the remaining electrons on the external atom and we don't count. We put them in as pairs, so there's a total of 8 around each external atom. We're not concerned right now as we do this about the total number yet. Just put the pairs in. Now we're going to run the test. Test number 1. We need to confirm that we've used all of the electrons. So I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we met test 1. Test number 2 is to confirm that we have 8 electrons around each of the atoms. So starting with the carbon, we have 2, 4, 6, 8. Yes. Then on the chlorines, we have 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, and 8. So we met the octet rule. So this is the best structure for carbon tetrachloride. Now we're going to move to the elemental forms of some elements. We'll start with O2. And again, we're going to count the total valence here. It's going to be 2 atoms of oxygen. It's out of group 6, so the grand total is going to be 12 electrons. That's the magic number. Now, in this molecule, what we're going to do is we're going to see how the steps are used to arrive at the correct structure. I need to emphasize at this point that the majority of students in Chem 7 and Chem 8 tend to want to memorize every possible structure on the planet, and then they're going to regurgitate them on the exam. That is a mistake. Now you're going to learn how to use the steps to identify a correct structure. So what we're going to do now, we've counted the total valence. This is the magic number. And now what we're going to do is see how we use the steps to get to the right structure. So following the steps, the next thing that we're going to do here is we're going to draw the skeletal structure. We just put the two O's side by side. Now what we're going to do is connect the two atoms the same way we've done in all the other structures. Then we're going to come in and we're going to add the remaining electrons the same way we've done this on the other structures. And we see that we're going to put pairs of electrons around the O's, so there's 8 electrons around each oxygen. Then we're going to go to step number 1. And we're going to count the total valence in this molecule now. So we have 2, 4, 6, 8, 10, 12, 14 electrons here. 14 electrons. And we see that that does not match the total valence. It does not match. There's too many valence electrons here. So we know that this structure is wrong. So now we start over. We put both oxygens side by side. And we noticed when we go back and analyze what we did with the first structure, that there are more valence electrons here than what should be in the molecule. And whenever there are more valence electrons than what we should have in the molecule, then the way we reduce this number is by adding double bonds. So what we're going to do here is we're going to add another bond here. And then we're going to add the remaining electrons so as to have 8 electrons around each of the oxygens. So here's a pair here, here's a pair here. That's 2, 4, 6, 8 for this one. And then over here we're going to have a pair and a pair. And that's 2, 4, 6, 8 around that one. Now we're going to go to the testing. And we see that we have 2, 4, 6, 8, 10, 12 electrons. And this number matches the magic number that we determined here. So this has met step number 1. We have the correct total valence. All right, and now step number 2. We confirm that we've got 8 electrons around both oxygens. So we have 2, 4, 6, 8. Then we have 2, 4, 6, 8. So we met octet rule. So this is the best structure. It's the correct structure. That's how we get to the correct structure. We follow the rules. We get the total valence count from the structure that we drew. We compare it back to the magic number, and then we redraw the structure until we get the total valences to match up in both cases. All right, we're going to go on now to another example. For this one, we'll do N2. Again, and moving quickly, we have 2 nitrogens out of group 5 for a grand total of 10 electrons. This is the magic number. We're going to take and we're going to place both atoms. Whoops, I want to change that color on that. Both atoms side by side. We follow the steps and connect the 2 atoms. We place the remaining electrons. So as each atom will have 8 electrons around it, we're not going to count anything yet. We're not overthinking this. All right, and we get a structure. We don't know if it's right or not. And then we're going to go ahead and run test number 1 on it. and count the total valence. So we have 2, 4, 6, 8, 10, 12, 14 electrons. All right, we see right away this does not match. No. So this is the wrong structure. So we start over. We put both ends side by side. Side by side. Now, we noticed here we have 14 electrons in the incorrect structure. We're required to use exactly 10. So we need to reduce this structure. And if you're clever about this, you'll see that you need to reduce it literally by 4 electrons. We go from 14 to 10. That's the equivalent of adding 2 more bonds to this. And then we're going to go ahead and add to a pair of electrons in the case of each nitrogen, so as to have 8 electrons, 2, 4, 6, 8, and then 2, 4, 6, 8 around the ends. So now we're going to retest. So test number 1, count the total, 2, 4, 6, 8, 10. All right, you can clearly see right away this matches the magic number. So this is correct for test number 1. Test number 2, we need to reconfirm that there are 8 electrons around each end. So we have 2, 4, 6, 8. This one's correct. Then we have 2, 4, 6, 8. This one's correct. So we met octet rule. All right, and this concludes the mini lesson.